part 3 of the rate law unit, or whatever you want to call it. But yeah, getting a little harder, but it's fine, we can do it. Again, since I'm assuming these are the homework problems she told you to study, I'm assuming that these are going to be the test, and something like this looks a little bit different than when I went over before, but don't worry, it's pretty simple. So we're going to go through how to solve it step by step. Okay, so your teacher here gave us a data table. In this column are the concentrations of C. In this column are the rates corresponding to those concentrations of C. And this is the reaction she's giving us. So part A is asking us to determine the order. And if you're looking at these and you're wondering, how am I going to use this data to find an order? I know, it's kind of confusing, but I will show you exactly what to do. So, let's get to it. Ah! I hate when that happens. And that was really weird noise made, sorry. But, alright. So, determine the order. There are only 4 plots, and they all are different numbers. So your best bet is, so I'll number the plots. So this is 1, 2, 3, 4. Your best bet is to take any 2 plots and divide them by each other. But I'm going to do plot 4, plot 2. And you're always going to divide the bigger one, so that's going to be the numerator, by the smaller one, that's going to be the denominator. So we're going to do concentration of C4 divided by concentration of C2. So now you can kind of visualize what I was just talking about, which is 1.2 m divided by 0.5 m. And when you type that in your calculator, you should get 2.4. Now you're going to do the same exact thing with rate 4 divided by rates 2. So rate 4 divided by rate 2 is 5.04 divided by 210, which is 2.4. And since those are the same exact values, that means they're first order. I'll write that down. Same values for and rate equals first order. So that's your answer for part A. Cool. And you could do that also with plot 3 divided by plot 1. You might get like a different value, but it's not going to be 2.4, but they're both going to equal out to each other and still be the same value. And I believe that's what your professor did in her homework example. And since they're both the same exact value, it still means it's first order. Part B, write the rate equation. So we know it's in first order. And we've probably already by now mastered how to write a rate equation. So rate equals K, concentration of C, because that's the letter she gives you in the example, is 1. Boom. Part B. Let's do part C over here. What is the value of the rate constant K? So now she wants us to put a numerical value to K, since we already have all the numerical values to concentrations of C and the rates. So what you're going to do is pick one row to use. Could be any row, but I'm going to use row number 2. So I'm just going to write that down over here so I don't forget. And if you remember before, this is the rate law you're going to use, and you want to solve for K. So we're going to divide by concentration of C. And this is the equation you're going to end up using, which if you should remember from last video, this is how we solved for KB4. I just knew algebraically showed you how to solve for that in case you ever forget the formula. Perfect. So we're using the data from row number 2. So we know that the rate is 2.10 and the C value is 0.5. You divide those together and you're going to get, by each other I mean, and you're going to get 4.2, whatever unit. She doesn't really give us a unit, I guess. This would be it'd be hour 1. So that's the unit for K. And no matter what row you use to find the K value, it's going to be the same because it's a constant. Sorry if you could hear, that's my guinea pig in the background. So same value for and that is how you solve a problem set given to you with rate tables. So hopefully that's a little bit helpful.